Notes 12C. Arithmetic and geometric sequences. Objective. I can determine terms in a sequence given a pattern. Essential question. What is the difference between arithmetic and geometric sequences? Here's some vocabulary for this section. We have arithmetic sequence. Skip counting by a common difference D. Use repeated addition or subtraction to find the terms. Common difference. How much is added or subtracted each time to get the next term in the sequence? Term. A single number or variable, or numbers and variables multiplied together. Terms are separated by plus or minus signs. Recursive. A rule that uses the previous term in an equation to find other terms. At least one previous term needs to be already defined. Explicit. A rule that gives a of n as a function of the term's positions number n in the sequence. Nth term. The desired term to find in a sequence. First term. The first term of a sequence. Term position. How many terms away from the first term? Geometric sequence. Counting by a common ratio r. Use repeated multiplication to find terms. A of n equals a1 times r to the n minus 1 power. Common ratio. How much is multiplied or divided each time to get the next term in the sequence? Alternating sequence. A sequence that alternates positive and negative terms. Series. The sum of terms in a sequence. Convergent. Where a sequence goes to a specific finite number. Divergent. Where a series does not go to one finite number. Here are some examples of an arithmetic sequence. Arithmetic sequence is skip counting by a common difference D. Use repeated addition or subtraction, which is multiplication, to find these terms. The sequence 1, 3, 5, 7, 9, so on. For each of these, you add 2 each time. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, and so on. So your common difference is adding 2 each time, so D equals 2. 3, 6, 9, 12, you're adding 3 each time, so plus 3. So D equals 3. 11, 22, 33, 44, you're adding 11 each time, so D is 11. Negative 6, negative 12, negative 18, negative 24, etc. You're subtracting 6 each time, so you put minus 6. D equals a negative 6. Now let's look at some geometric sequences. You're counting by a common ratio r. You're using repeated multiplication, exponents, to find terms. So we have 64, 32, 16, 8, and so on. You divide by 2 each time, which is also the same thing as multiply by 1/2. So r equals 1/2. 10, 100, 1000. Each time you're going to multiply by 10. So r equals 10. Negative 5, 25, negative 125. Well, we know that we're multiplying by negative 5. We'll multiply this one by positive 5. Notice that the sign changes, it alternates. So in addition to having your minus 5, you're also going to have negative 1 to the n minus 1 power. Or actually, in this case, it would be to the nth power. And then the last one, 4, 12, 36, each time you're going to multiply by 3. R is 3. Okay, let's practice. Determine the 8th term of the following sequence. 7, 14, 21. Each time we're going to add 7, so this means that it's an arithmetic sequence. So let's recall that formula from before. We have A of n equals A1 plus D times n minus 1. So it says the 8th term, so n equals 8. D is our common difference. We're adding 7 each time, so D would be a plus 7. So we'll write that right there. A1 is our first term in the sequence, which is 7. So we just plug these in to get A of n. So we have 7 plus 7 times 8 minus 1. We have 7 plus 7 times 7. That's 49 plus 7. $56. So our 8th term in this sequence is 56. Determine the 5th term in the following sequence. 7, 14, 28. Well, this time, if we try to do plus 7, 14 plus 7 is not 28. Be careful with that. Sometimes the first term in the sequence would work and the second one does not. So instead of adding, looks like we're going to be multiplying by something. 7 times 2 is 14. So let's try that. 7 times 2 is 14. And 14 times 2 is 28. So that looks like it works. So this is going to be a geometric sequence. And let's recall the geometric sequence formula. We have A of n equals A1 times R to the n minus 1 power. Now let's identify each of these in the equation. So A of 1 is our first term, that's 7. R is our common ratio. We're multiplying by 2 each time. N is going to be 5 because the 5th term. So we'll put the 2 here. The first term is 7. The term that you're looking for is the 5th one. Let's plug in A of n. A of n equals 7 times 2 to the 5 minus 1 power. So we have 7 times 2 to the 4th power. That's 7 times 2 times 2 times 2 times 2. That's going to be 7 times 16. And when you multiply that together, you get 112. So 112 is your fifth term in this geometric sequence.